Let's talk about note card 31. We're going to be solving quadratic equations. It's pretty much a step further than what we were doing when we were factoring. So if I come up with an equation like this one right here, x squared minus 10x plus 21 equals 0, and I want to solve for x, the first thing that I have to do is factor this. And so go through our trinomial factoring that we've been doing. A is 1, B is negative 10, and C is 21. Signs are going to be the same. They're both going to be negative. So I'll multiply A times C, which is 21. Then I look at the factors of 21. 21 times 1, 7 times 3. And if they're both negative, which set adds to negative 10? It's these two at the bottom. So I divide by A, which is 1. And I get x minus 7 and x minus 3. And that's what I have over here. X minus 7 and x minus 3. But how I finish is to solve for x. This whole thing, this trinomial set equal to 0. So I have x minus 7 times x minus 3 equals 0. So all I have to do is take each factor and set it equal to 0. X minus 7 equals 0, x minus 3 equals 0. Solve for x, and I get that x is equal to 7 and x is equal to 3, and I'm done. So we already know how to factor. The only new thing here is, which is not new, this is still review, but the only thing new to this year is you take each factor, set it equal to 0, and solve for x, and then you have your solutions, or your roots or zeros. Okay, the next way we're going to talk about is using the calculator. And so if I want to use my calculator and have the same function that I just had, what was it? Put the trinomial or whatever quadratic equation you have into y equals, and then just follow these steps. The first thing you want to do is zoom 6. That takes you to a standard screen. And the reason you want to do zoom 6 is because maybe you were working with the function a minute ago or a second ago, and you had to readjust your window, maybe to zoom 0 for zoom fit or something like that, or change your x min, y max, something. And so you want to start off with zoom 6, which takes you to the standard screen. And we already put our equation in y equals. You can do that first if you want to. It says second, but you can do it first. Then you do second trace, and then 0, which is number 2. And 0 is another word for roots or solutions, so you hit number 2 there for zeros. And then what we have here, and sometimes people get confused with this, so I'm going to try to spend a minute and make sure we are very clear on what's going on here. It's going to ask us for the left bound and right bound. The first thing you need to know is there are two roots. We have this root and we have this root. There's two of them, right there and right there. And so I have to do what I'm about to do 2 times. I have to find the left side root and the right side root. But what's going on right here, I think what confuses people is this is saying left bound. This does not mean this left-sided root. What this means is, if I draw a line, a vertical line, right through that root, it's kind of right through it. When it's asking for left bound, if I'm looking at this root here, there's vertical line here, it separates the root to a left side and a right side. And on this particular root right here that I'm looking at, the left bound is a little bit to the left of the root, and the right bound is a little to the right of the root. Okay? So let's go ahead and do this quickly. Let me move this out of the way. So it's asking for left bound, so I have to find my cursor. There it is. So I'm approaching this first root that I'm going to look for. Well, this is a little bit to the left of it. It doesn't matter, 1 or 2, 3 clicks, hit enter. Now it's asking for the right bound, so I go a little bit to the right of it. 1 or 2 clicks, doesn't matter. Then hit enter. And now it says guess, and you see that the root is x equals 0. That's this one right here, and you've got, 3. And so you've got this one right here. Now we have to do it again for this side. So again, if I were to draw a vertical line through that root, now when it's asking for left bound and right bound here in just a second, this piece over here, underneath it is the left bound of it, and up above is the right bound of it, because the function continues up this way, and so the right of this root is on this side, up above the x-axis, and on the left side is down here below the x-axis. And that confuses some people, so hopefully that helps out a little bit. So if I'm going to find this one again, I do second trace 0, which is number 2. It's asking for left bound, so I have to scroll around here to the root. And in this case, left bound is going to be a little bit below the x-axis, so I hit enter. Now it's asking for right bound, so I want to go a little above the x-axis because this is to the right of that root, and hit enter. And now guess, and I see that that root, or 0, is 7. That's how you do it with a calculator. Now moving on, if I want to, sometimes when you have a quadratic, sometimes they are not factorable, okay? And while you can take a quadratic that's not factorable and you can find the roots using the calculator, sometimes you may not be given a calculator. You may not have a calculator. And so what you have to do is, if it's not factorable and you don't have a calculator, you have to use the quadratic formula. And this is something that you first learned in Algebra 1. It's on all the formula charts for tax testing. And it's negative b plus or minus square root b squared minus 4ac all over 2a. And so the example that I want to do here, so how does this work? Well, up here in my formula I have an a, b, and a c. And so those are still the same. A is 2, B is 3, and C is 5. So all I'm going to do is, if I needed to, I can rewrite this entire formula, putting a set of parentheses everywhere I have an A, B, or a C. If that helps, you can do that. Some of you may not want to do that. So what goes in this set? A B. So B is 3. Here goes, in this set of parentheses, another B. So there's a 3. Here I need to put an A, which is 2. Here I need to put C, which is 5. And down here I need to put A, which is 2. Now, you have to do this in the right order. You have to use PEMDAS, or order of operations. This is how it works. This negative 3 out front, that's just negative 3. Then plus or minus square root. Where most people make their mistake is right under here. You have to follow order of operations under here. First you do your exponent, which 3 squared is 9. Where the mistakes typically come in at is when they square this term here, they want to subtract this 4. Do not do that. Because what you have to do is, you want to square this term first, and then you want to do all of this multiplication second. So negative 4 times 2 is negative 8, and negative 8 times 5 is negative 40. I'll show you again. First square the b, write it down. Don't skip this step. Then these three numbers here must be multiplied. Negative 4 times 2 is negative 8, and negative 8 times 5 is negative 40. Over 2 times 2 is 4. Now, continuing to simplify, I have negative 3 plus or minus square root of 9 minus 40 is negative 31 over 4. Now we're going to get this review of imaginary numbers. What I have here is a square root of negative 1 underneath. And the square root of negative 1 is I. So if I need to go in different steps here, here's how it would work. Negative 3 plus or minus square root of negative 1 times 31 over 4. Negative 3 plus or minus the square root of negative 1 is I, so that comes out, and then I have square root of 31 over 4. And I'm done right here. And the reason I'm done is I can't simplify square root of 31. I do not want decimals. I can't find two numbers that multiply together to get 31, one of them being a perfect square, because that's how we would be able to simplify that. Another thing, I do not have an example for it this time, but when you do these problems, when you think you're finished, you need to look at this term, and the number in front of the radical. If these three pieces have a common term, you need to reduce by that term. This one does not, I'm done. So hopefully this note card serves as a good review, and I'll give you lots of good practice. Yeah.